irreparable changes to the export. Now let's go ahead and export another directory. Just to have it reflected using export FS, we'll make directory NFS2. We'll modify the exports file, and in this case we'll allow the same host to connect, 7510, but this time the user will be restricted to read-only rights. You may update your exports without restarting the NFS server. So second task, export /NFS2. Create entry in etc exports, and then to update the currently exported directories, use export fs-a. So update current exports using export fs-a, and then we'll confirm with -v. And let's try that. Now we have another mount point which is read-only. So we have two items to confirm from a client perspective. So then our third task, the next logical task, is to mount both exports on a remote system. And to do so, we'll connect to the remote system Linux CBT serve 1 and then execute mount type NFS, the path to the server, which is its IP address, followed by the path to the mount or the export point, which is NFS1, followed by the local mount point, which we'll also label as NFS1. And we'll repeat this, changing NFS1 to NFS2 to take care of the read-only mount point. So we have two directives to follow. Now on the local system, let's be sure that the directories exist by using make directory NFS1 as well as NFS2. They now both exist. We'll reset the buffer and attempt to mount the remote item to our local directory. And this will contact the box 192.168.75.199 in search of an export path of /NFS1 and attempt to mount it locally at /NFS1. So we've gotten an exit status of 0, which means things should be fine. df-h will confirm if the item's mounted, and it is. We see status information. Mount also tells us if it's mounted. Mount also tells us whether or not the volume is writable. So with that said, if we navigate to NFS1, we'll see that nothing exists. Let's sequence 1000 test from Linux CBT serve1.txt. Permission denied, and that's because we've been assigned the anonymous user ID. When we exported the volume, we decided to squash root, which made root on the local system equivalent to anonymous on the host system. Let's also mount NFS2, so we'll re-execute our mount command but changing NFS2 or 1 to 2, and then a df-h will show 2. A mount, however, will reflect read-write as opposed to read-only, but the effective permissions when we navigate to NFS2 will be read-only. Let's try to write a file using sequence, and it tells us it's a read-only file system in spite of the fact that read-write is apparent in the mount dump. So one tells us read-only and the other tells us permissions denied. So our next task is to allow local root user the ability to write to NFS1 export. And to do so, we'll change one of the options in the export file, the etc exports file, on the host system. We'll indicate no _root _squash, which will override the root _squash for the export of /NFS1. So let's nano exports, and for this guy we'll just include the new option, read write comma no underscore root underscore squash. This will ensure that we mount the remote item appropriately. Let's save the changes and update our exports using exports or export FS-A followed by export FS-V to see the current settings. And now note /NFS1 is exported using no underscore root underscore squash, which means when the remote or the client root user attempts to mount this export, they'll have full root access. But of course there are caveats with that as well, which is why you probably will want to run or use NFS within a closed environment, within a controlled environment. So back to our client system. We can umount /NFS1 and then remount it. This mount will still reflect read-write in both cases. The big difference being this time is that if we navigate to NFS1 and attempt to write a document, this time sequence 1,000,000, to test from Linux CBT serve1.txt, the file writes, and that's because we've indicated no underscore root underscore squash. That root should not be squashed or equated to anonymous. So now the file exists. There it is, 6.6 megabytes. We can interact with it using any of the programs that we'd have at our disposal. And on the host system, serve4, if we navigate to NFS1, you'll see the file. And there it is. So we can also interact with it here. So now both systems, the host and client systems, are sharing the same export, one locally and natively, and the other remotely using NFS. Which leads us to our next task. And we'll just indicate step A, modify in etc exports the options to read write, no underscore root squash. And that is to set up mount points so that they're available upon reboot. To do so, we update the appropriate file, etcfs tab, or the file system table file. In there we'll indicate the type of file system. So let's navigate to the shell on the local system, and then nano etcfs tab. In here we'll make some space, we'll just call it NFS mounts, and indicate the path to the share, which is 192.168.75, in this case 199:NFS1, followed by the local mount point, which is /NFS1. The system type is NFS, and the options should be read write, no underscore root underscore squash, followed by no check. And we can duplicate this for the NFS2 mount. Now this is a read-only mount point, so we'll indicate read-only, no root squash, but it's not required since we won't be able to write to the mount or to the export. So read-only is sufficient, with no check when the system boots. So here we've got two entries such that when the system changes run levels or reboots or starts after having been shut, both NFS mount points will be made available, providing the network is up and running and the host NFS server is indeed sharing /NFS1 as well as /NFS2. And in fact, if you were to unmount using umount both NFS mount points and remount using mount-A, both NFS mount points would be attempted, and if successful, they'd be made available. So as a case in point, let's umount, and you cannot umount if you're in a directory, so let's navigate out of it. We'll umount NFS1 as well as NFS2. So now that we've made the changes to etcfs tab, step B is to unmount and confirm that NFS mount points will be available when the client system changes run levels. For example, reboots, starts, etc. And we can do so using mount-a. Again, mount-a will read the etcfs tab file and mount the file systems listed in it, or remount them if necessary. And before doing so, let's just confirm our etcfs tab entries. We'll nano etcfs tab. We may have placed an entry that should be in exports, and that's correct. So it should be defaults, and for this option, simply no root squash. That's more like it, as opposed to read-only and read-write. The read-only and read-write is determined